This is section 6.2, day 2 notes over U substitution. Students will be able to evaluate integrals using substitution. Well, let's pull the 6 out of this. And we have the integral of 1 over x squared plus 81 dx. Now, if we could get this to say 81u squared, then we could factor out the 81, and we're going to do inverse tangent. So we're going to let u equal x over 9, and 9u is equal to x. So we'll multiply the 9 over. Take the derivative of this, which is 9 du equals dx. So now 1 dx right there is equal to 9 du. Let's go 9 times 6 integral du. So we replaced 1 dx with 9d, that's a u, du. And then we have 1 over, and if we put 9u in for x, we'll have 81u squared plus 81. Ooh, thing's really acting up. Let's factor out an 81. We have 54 over 81, integral of 1 over u squared plus 1, because we factored out the 81 here. Well, now that's inverse tangent. Does 9 go into both of those? 6 over 9, 2/3. 2/3 inverse tangent, because the antiderivative of this is inverse tangent, of u, which is x over 9. So x over 9 plus c. Over here, let's let u equal 3x squared plus 5x, and du is 6x plus 5 dx. So we have exactly the derivative. We have a function and its derivative. Now we're going to integrate. Let's change these x's to u's. So when we plug in 2, we get 12 plus 10, 22. And when we plug 1 in, we get 3 plus 5, which is 8. So 8 to 22 of 1 over u du. So we get natural log of absolute value of u from 8 to 22. And that is natural log of 22 minus natural log of 8. And that's natural log of 11/4. Here we're going to let u equal 7x minus 2. So du is equal to 7 dx. But we don't have a 7 dx, we have a 28 dx. So 4 du is equal to 28 dx. Now we're going to replace 28 dx with 4 du. So 4 du, and we're going to go u to the third. So we have 4 times 1/4 u to the fourth, and plus c. And then those cancel out. So this is just going to be 7x minus 2 to the fourth plus c. Over here, let's let u equal 1 minus cosine of t over 2. So du is equal to the negative sign. That's going to be sine of t over 2, but times 1/2 dt. Well, we have sine of t over 2 dt. We just don't have the 1/2. This is 2 du is equal to sine of t over 2 dt. Now we have the sine t over 2 dt here. And that's going to be replaced with 2 du. And then we have u squared. U squared. So 2 times 1/3 u to the third plus c. So that's going to be 2/3 times 1 minus cosine of t over 2 to the third plus c. 24. Let's let u equal y to the fourth plus 4y squared plus 1. And then the derivative is 4y to the third plus 8y dy. Well, we kind of have that. We have y to the third plus y, kind of. But if we factor out a 4, we're going to get this exactly. So this is the same as 4 times, let's see, y to the third plus 2y. Ugh, why does it keep doing that? I promise I'm not actually drawing that. Plus 2y. But we have an 8 here. So if we multiply both sides, if we multiply that times 2, then that becomes 8. And now we have exactly 8 y to the third plus 2y dy. dy. So this, and this becomes 2 du. 2 du, and then that is going to be, we're going to have u squared there, u squared. So 2/3 u to the third plus c. So 2/3 times y to the fourth plus 4y squared plus 1 to the third plus c. On 28, the derivative of secant is secant tangent. So this is secant theta plus pi over 2 plus c. Over here, let's let u equal 5x plus 8. du is equal to 5 dx. And we don't have a 5 dx, we just have a 1 dx. So 1/5 du is equal to dx. So dx is the same as 1/5 du. 1/5 du, and then we have 1 over the square root of u. So 1/5 integral of u to the negative 1/2 du. Now we can take the antiderivative of this, and we're going to add 1, which is going to be a half. So we have 1/5, and then times 2 times 2u to the 1/2 plus c. So 2/5 times the square root of 5x plus 8 plus c. Here we need to replace this cosine squared. So let's get this cosine squared by itself. Let's add 1 over. Cosine of 2x is equal to 2 cosine squared x. Oh, plus 1. I need a plus 1 there. Plus 1 equals 2 cosine squared x. Divide by 2. So cosine squared x is equal to 1/2 cosine of 2x plus 1/2. Now when we replace cosine squared with this, when we distribute the 4 through, these become 2's. So we're taking the integral of 2 cosine of 2x plus 2 dx. This is going to be sine of 2x plus 2x plus c. So that's the antiderivative. The derivative would be cosine of 2x, but then times 2, which is exactly that. Here, let's let u equal the tangent of x, and du is equal to secant squared of x dx. We can change our u's, so the tangent of negative pi over 4 is negative 1. So now we're going to integrate from, oh wow, why is it so squiggly? It's like it has a mind of its own every once in a while. All right, integral negative pi over 4, tangent of negative pi over 4 is negative 1, and tangent of 0 is 0. So we're changing these x's into u's. And this becomes du, and tangent is u, so u du. And that's going to be 1/2 u squared from negative 1 to 0. That's a negative 1. And we have 0 minus 1/2 times negative 1 squared. So it ends up being negative 1/2. Let's let u equal t to the 5th plus 2t. And du is equal to 5t to the 4th plus 2. Which is exactly this, dt. So now, if we change the x's to u's, if we plug 1 in, we get 1 plus 2 is 3. So we're integrating 3. If we plug 0 in, we get 0, and that's going to be square root of u du. Well, that's u to the 1/2. So we have u to the 3/2 times 2/3 from 0 to 3. So we have 2/3 times 3 to the 3/2, and then minus, that's just going to be 0, and we plug in 0. So the answer is 2/3 times 3 to the 3/2. On 60, let's let u equal cosine of 2 theta. So du is equal to negative 2 sine of 2 theta. Well, we don't have the negative 2, so let's get that over here. Let's go negative 1/2 du is equal to sine of 2 theta, and I forgot the d theta here, d theta. Now this part right here goes to negative 1/2 du. So du over here. And then we have u to the negative third. U to the negative third. And we can change the x's into u's. The cosine of 0 is 1. And the cosine of pi over 3 is 1/2. We have negative 1/2 times, if we add 1 to this, that's u to the negative 2 times negative 1/2. So there's the integral, and then that negative half is just tagging along. So 1 to 1/2. Let's just leave this out here. Not that you'll get the same answer either way. We have 1/2 to the negative 2 is actually 4. So negative 1/2, let's go negative 1/2 of 4, and then plus, because we have minus negative 1/2. Negative 1/2 times, that's going to be negative 4/2 plus 1/2, that's negative 3/2. And we end up with 3/4. Well, this one is the natural log of the absolute value of x plus 2 from 0 to 7. So natural log of 9 minus natural log of 2, so natural log of 9/2. Over here, this is going to be 1/2 times the natural log of absolute value of 2x minus 3. And we're going from 2 to 5. So we have 1/2 natural log of 10 minus 3 is 7. Minus 1/2 natural log of 4 minus 3 is 1, but that's 0. So we have the natural log of the square root of 7. Cotangent. Well, cotangent is cosine over sine. So we need the natural log of sine of x. And if we took the derivative, sine would be in the bottom, and then times the derivative of the inside, which would be cosine. So we'd have cosine over sine. That's the antiderivative of cotangent, from pi over 4 to 3 pi over 4. So we have the natural log. Well, the sine of 3 pi over 4 is negative square root of 2 over 2, but then we have the absolute value. Minus natural log of sine of pi over 4 is square root of 2 over 2. So the final answer is 0. On this one, let's let u equal 3 plus e to the x. That way du is e to the x dx. And that's exactly what we have here. Now this is the integral from, well, let's change the x's into u's. Plug 0 in. 3 plus 1 is 4. So we're going from 4 to 3 plus e squared. 3 plus e squared. And this is going to end up being 1 over u, du, which is the natural log of absolute value of u. And now we change those to u's. And we're going from 4 to 3 plus e squared, which is natural log of 3 plus e squared minus natural log of 4. So natural log of 3 plus e squared over 4.